Hi, welcome to another lesson at Edu Solutions Institute. Now, today we'll be looking at the CSEC Physics. Now, we are still on the aspect of forces, the effect of forces on motion, on shape, size, direction. Now, today's lesson will be more on pendulum. Now, the pendulum is a simple setup that we use to demonstrate the link between different quantities. Now, the pendulum is any mass that is attached to a string and is allowed to swing freely. So here we have a simulation that demonstrates a small mass here that's attached to a string that is fixed at the point at the top here. So therefore, if we move this mass to an angle, any side, left or right, and we release it, then it causes it to rotate or it oscillates around the rest point, which is a dotted line. Now, the specific terms that we will need to consider would be the oscillation. What is an oscillation? Now, an oscillation is the forward and backward motion of the pendulum. Now, if we consider when the pendulum is on the left side, when it goes to the right and then back to the left, that's one oscillation because it has moved a complete cycle, right? So a complete cycle of motion is called an oscillation. Now, a next term that we note is the period or the periodic time. And this is the time it will take to do that one oscillation. So if we get stopwatch here, and we try when it's on the left, and stop when it reaches back to the left, this 1.57 seconds will be the time for the periodic time of this specific length. Now, you might be asking, what is causing it to oscillate? Now, the reason why it's moving from side to side is because there is a force, and that force is called the gravitational force that is pulling down each time the object goes to a maximum left or right. It pulls it down, right? And then you get that side to side motion. Now, another thing that we will have to consider in this type of situation is what are the factors that will affect how fast this pendulum is swinging. Now, the first thing that we'll consider is the length of the pendulum. So if we stop the pendulum and we notice on the right side here, we can make the pendulum shorter or longer. So if we move it at a longer, put it at a small angle, and release it, we can see it moves relatively slowly. Now if we stop it and go to the shortest distance, move it again to the same angle as before and release it. Notice its speed speaks up. So now it's completing the oscillation at a faster rate. So therefore, what we notice here is that when we have a short length, the periodic time will be short. And that's because the distance traveled is less. But if we have a long length, then that means it's going to travel a longer distance, its speed is short, and hence the periodic time will be high. So the relationship between periodic time and length is that they are directly proportional, which means as the length increases, the periodic time will also increase. All right. Now, another thing that will affect the periodic time is the angle that we displace it at. So if we displace it at a big angle, then it will take a longer time than if we placed it at this small angle. And that would be obvious because at larger angles, it will travel a longer distance to complete that oscillation. All right. So these are factors that affects the periodic time. All right. Now, do you think the mass will affect it? Let's do that in practicality, and let's go with a very small mass. All right. We're going to put it at a constant angle of 10 degrees. We're going to release it and we're going to time it when it's on the left side for one oscillation. 1. So that is 1.87. All right. Now we're going to increase it to the maximum mass it gives. And we're going to do that same setup. So 1.87. And we get 1.88. Now you notice the values are quite the same. And what this tells us is that the mass of the pendulum does not affect our periodic time of oscillation. So if it's a big mass or a small mass, the time will still be the same. So we only will identify two factors that will affect the time: the angle that we displace it at, as well as the length of the string. Now, when we do this experiment in the lab, we do not do it like we just did, where we did one oscillation. Because in practicality in the lab, it's very hard for us to time one oscillation. So what we do is to time 10 oscillations. So we allow it to swing 10 full oscillations and time that motion. And then to find the periodic time, what we will do is to divide it, the answer we get, by 10. And that will give us an accurate value of the periodic time for the specific length, right? So that's basically what we do in the lab as practicality, right? And the reason why we do that is because we have something called the reaction time. And the reaction time is how fast we can start or stop the stopwatch. And therefore, if we want to make a full oscillation, the reaction time will take part in delaying the accuracy of the time. So if we time it for a longer period, then it accounts for the reaction time. So hence we get a more accurate value. All right. So the pendulum is very simple, and the purpose of the pendulum is that it's used as a timing mechanism. So if you notice those old clocks, all right, those standing old clocks, they normally have something at the bottom swinging from side to side, because the invention of the pendulum was to aid in keeping time. All right. And as we can see, if it's a specific length, it is oscillating at a uniform time each time. Now, in reality, this does not happen, because as you know, from the video started, we are oscillating this object. It's going to the same point every time. And that's because there is no air resistance. Now, if we include air resistance, it will make it shorter. All right, so notice the angles getting smaller and smaller. And that's what happens in everyday life. Because we have air particles, it's going to affect the oscillation. So what we do is we ensure that when we're doing this experiment, it doesn't go swing for a long period of time, because if it swings for a long period of time, the air resistance will cause the oscillations to get smaller and smaller. All right, so that's it for the pendulum. So I hope you understand a little bit more on the pendulum, and I'll see you next week where we continue to learn about the CSEC syllabus. Thank you.